Hi guys, today we're going to talk about permutations. But to be able to talk about permutations, we actually have to talk about an idea called factorial first. So when I have a factorial, that means that I multiply whatever number they give me and all the numbers that are below it up to 1. So, and one thing to remember is you can always identify it by the fact that it has an exclamation point with it, which is very different from math. So if I have this right here with 5 and then the exclamation point, it's read as 5 factorial. And 5 factorial is I start with the number 5 and I multiply it by every whole number that comes after it up to 1. So 5, 4, 3, 2, 1. So that factorial equals 120. So it's actually a way that you can use to be able to kind of write multiplication of a set of numbers very quickly. Factorials are used a lot when they write formulas, especially to calculate probability ideas. And so today we're going to start with a probability idea of permutations, and we're going to use factorial within it. So let's make sure you have this idea of factorial kind of taken care of. So if I have an example of 10 factorial, that means I would have to multiply 10 by every whole number up to 1. Now, really multiplying by 1 doesn't matter, but it is helpful just to make sure that you have all of the numbers there that should be. So if we go through and multiply those, that would be 3628800. So that would be 3,628,800. So having big numbers like that can be, very cumbersome to deal with. That's obviously why they use something like this. Okay, so let's look at the next one. The next one is 7 factorial. So that means start at 7, go by every whole number that comes after it. So 7 times 6 times 5 times 4 times 3 times 2 times 1, which would be 5,040. Now, if you're going through to calculate this, it is very helpful to be able to kind of have a calculator off to the side that you can plug these things into to kind of check them. So let's see how you use this. So permutation is when you arrange objects and you have to arrange them in a certain order. So they often use a formula. Our formula here is our formula for permutations. You'll notice that they use both an N and an R in here. So N is the number of things that you choose from. So N is your total number of things. And R means how many you're choosing in each group. So sometimes the notation looks a little bit like this. They may use N and R like this, but you'll see they do N factorial, so however many total number of items you have. This is your total number of items, and that's how many you're choosing. So it's N minus R factorial on the bottom. So that can be kind of difficult because you haven't really used formulas that complicated before. So let's go through a couple so you can see how this works. So first of all, let's just talk about possibilities. So if I want to talk about arrangement of items, they want us to list all the possible permutations. So instead of just calculating them, we're going to list them. So if I have the numbers of 1, 2, and 3, they want to know what possible ways I could write that down in which order is unique. So 1, 2, 3 is one way to write them. It's the only way in which 1 goes first, 2 goes second, and 3 goes first. Now, if 1 is first, the only other combination you could have is if I get 3 and then 2. So those are the only combinations you can have where 1 is first. So let's put 2 first. So if I do 2 and then 1 and 3, the only other combination I could have would be if 3 went second and 1 was last. Okay, if I look at having 3 first, it could do 3, 1, 2, The only other possibility with 3 first would be if I did 3, 2, 1. So there's 6 possibilities of total permutations in that, and these are the very specific order that they can be in. So let's try it one more time, but let's try it with some letters. So if I have T, V, and W, and they want us to be taken 2 at a time. So let's start with T. So T and then V would be 2 letters that I could do out of the 3 taken in order. The only other 2 that could have a T first would be TW. Now if I go to V, I could do VT. The only other one that would have V first is VW. Now if I look at W, I could do WT or I could do WV. So this would have 6 possibilities. Okay, so you kind of get the idea of how to list them if you needed to. So let's look at how you can actually use the formula. So here's one that we have right here. You have 4 permutation of 2. So this right here would be your N value. So N is 4. This right here would be your R value, so that's 2. So to calculate this, remember, we follow this formula. So we're going to plug them in there. So that means that N of 4 is going to go here, and R of 2 is going to go there. So it's going to be 4 factorial over 4 minus 2 factorial. So if I were to look at this, let's see. On the bottom, 4 minus 2 is going to be 2, so it's 2 factorial. So let's expand it. So 4 times 3 times 2 times 1 is the 4 factorial. In the bottom, it's 2 times 1, which means you can kind of see those would cancel out. So that just really leaves us with 4 times 3 on the top, which is going to be 12. So if I were to write, oops, might have to have a pen there, 4 permutations of 2s, that's going to equal 12. Okay, let me show you one more. So if I have this, this tells me that my N is going to be 5. And this tells me R is going to be 1. And I am plugging it into this formula. So 5 is going to go in for the N's here. R is going to go in as 1. So it's 5 factorial over 5 minus 1 factorial. So on the bottom, 5 minus 1 is going to be 4. So now let's expand. So 5 times 4 times 3 times 2 times 1. And on the bottom, it's going to be 4 times 3 times 2 times 1. So you can see those are all going to cancel out. And you're going to be left with 5. So let's see. This is going to equal 5. Okay, the next one we're going to see is going to be combinations after this.